This is our final project brought to you by Crush Mining Incorporated. So the demand for certain materials and minerals are increasing on Earth. However, the supply is very low. Humanity would need to start utilizing other planets in the solar system. After doing much research, it has been shown that Mars has many minerals needed on Earth, like iron, titanium, nickel, aluminum, magnesium, and calcium, and many other more. Our company, Crush Mining, has been given the honor of designing a mining machine that allows for strip mining on Mars. Our mechanical system will be similar to mining machines on Earth, however, modified to survive on Mars. The system will be launched by 3 rockets.
So here are the main constraints for our design. The mechanism must be able to withstand and operate in freezing temperatures of this planet. A gearbox must be designed as a speed reducer between the motor and the bucket wheel. And the machine should have some transportation system for moving the minerals from the bucket wheel to the dump truck. And also safety features need to be incorporated for the operators to easily enter and exit the cab. So for this design, the estimated cost should be no more than $10 million. And here's some images of the final design in SolidWorks. The machine consists of a rotating base with 2 mining arms that can be moved using the hydraulics. At the end of the front arm is a bucket wheel for the strip mining, and at the end of the back arm is a rock crusher. Both arms have conveyor belts that will transport the minerals from the bucket wheel to the rock crusher. The minerals will then be collected in a dump truck, which will be under the rock crusher, and then transported to another location.
The final design for our machine consists of a motor-driven bucket wheel as seen in this motion study. As the bucket wheel rotates, each bucket digs into the mountainside and extracts a lump of minerals. These minerals are then transported down the length of the machine on the conveyor belts and then are directed into the rock crusher where they'll be crushed and collected into the dump truck for further processing. Now looking at the left side first, you can see both support arms are situated on a base that is free to rotate 360 degrees about its center, ensuring that it can mine along a mountainside and can be maneuvered as needed to mine various parts of the mountainside. The base itself sits on top heavy-duty tracks, and these tracks allow the machine to navigate across the difficult terrain. Now looking at the rock crusher system on the right side, you can see it is a system comprised of 2 main plates that break up the large rocks. The top plate is attached to an electric motor by a chain drive and is designed to oscillate back and forth, breaking up any large rocks, while the bottom plate is fixed to the protective cage that surrounds the rock crusher.
Okay, so calculations and analysis were also a major part of this project. Overall, we did ball bearing life, fastener length, and fastener stiffness, gear train speed and torque, and then fatigue failure. Today, we're only going to talk about the last 2. So on this slide, you can see that we're going to use gears with a 20-degree pressure angle and a pitch of 3.2 teeth per inch. We're going to want to reduce our speed down to around 11 or 12 RPM. So that ended up being a decrease of around 107. And then you can see the torque after the whole gear chain will be about 1.1 million pounds per inch. And then this is our fatigue failure calculations. So using that same 11 RPM, and the specialized steel meant for cold temperatures with a ultimate stress of 560 MPa. We can see we calculated the cycles to failure, which ended up being 6.9 times 10 to the 11 cycles, so that this should not break any time in its lifetime without serious misuse.
So in conclusion, there still needs to be more analysis done on the subassemblies. First thing is the fasteners and brackets. We are expected that we will need more to support all the components. We also question if 300 horsepower motor is too much powering the bucket wheel. It could cause damage to the gear and gearbox as well as the pinwheel. Lastly, our design is rated for negative 60 degrees Celsius. However, a lot of temperatures on Mars could get colder than that.
All right, and then here's our team in the West Lab looking at our final assembly, and then on the left is our team titles. I hope you guys enjoyed our design. Thank you.